Hello everyone, it's March the 2nd. I didn't do it yesterday. Was busy working on the app, and yeah, just didn't have time. And today I had a midterm exam, and then so I have to wait until now. So we had to use the time travel again. So it's like the second time travel in like 3 days. It's pretty bad. All right. Anyway, let's just first get. This is actually for yesterday, right? So let's get this done and do another one for today. Fortunately, the one yesterday was an easy question, so hopefully we can get this done fairly fast. Oh, it's a new question. Huh? All right, given two string s and t, return true if s is a subsequence of t, or false otherwise. Subsequence is when you delete, right? You delete some. Okay, so we want to see if s is the subsequence of t. Suppose, oh, and there's follow up. There are lots of incoming s, say all these, where k is larger than, oh, and you want to check one by one to see if t has a subsequence. In this scenario, how would you change your code? So s is 100, t is this long. Okay, so we have to check. I mean, for this one specifically, all we want to know is, I feel like I've done this before. Yeah, I feel like I've done this before. And for this, because s is smaller, right? So, of course, we prefer to check the length. If the length is not the same, I mean, if t is smaller than s, then there's a no-go. Okay, and if t is larger than, then we can just walk one by one. 2 pointers, right? Yeah, we have 2 pointers. One is the same, we just move, and this one gets keep moving once it's the same. Yeah, so we will move on t, and then whenever we have a match, we move this. Right, so this will get it done in, I don't know, on was this. Yeah, I think this is how I will solve it, but I don't have anything to say about the follow-up. All right. So what we have is I, right? For I, it's actually not for I. I can just say for letter in S, right? And we have I equals to 0 if letter equal to ti, I plus equal 1. Right, and then if I is equal to len t, then return true. Return false. So S will just go one by one, and every time we make a check with the current t. If it's equal, we move I forward. And check, check, check. If it's equal, we move forward, right? Just keep checking. And then if, yeah, I think this one shall be it. Let's give it a shot. True. This shall be false. Oh, I got it wrong. This is T. T is a longer one. This is S. Alright, of course, I have like ABC, BC, AB, that should be false. Yeah, I believe this shall be right. Oh, maybe test the empty case. It's all different cases. Yep. One of them didn't pass. Sure. What I can do is I have put this one here. I is 0 equal line S, which means if S is an empty, then it will always return true. That is not right. If letter is equal to Si, then I plus 1. Alright, so let's do it back. All we needed is to check if S equal to I. No. If I is I, that's what we have to do. N equals line S. Okay. So if I is smaller than N and this if it's equal to N, this one shall do. No, I think the last one. True, true, false. How will we break it? Alright. And I'll return I is equal to N. There you go. This might be right. Yeah. Yeah, what I used for yesterday. Okay, so it looks pretty bad. Go ahead. I have a few good test cases and believe this and this is true, right? And this is false. No, this is true. This and this is false. But we did have to go through, so this is quite a naive solution. 392. This is quite naive solution and it feels stupid to me. When where n equal to len s. Well, actually no. It depends on length t. %. ranking. I mean, one thing we can do is say if n is larger than length t, that return false immediately. Right now, n s is smaller than t. Then what? How about I don't know, let's get t into, right? And then we have like a dictionary with their indices. Okay. Now when s comes in, everything will just look, right? For the first one, now we have the indices. And then the second one comes in. We want to know if we get the smallest. Okay, we get the smallest of each one. Yeah, we get the smallest of each one. We get the smallest of occurrence of each letter in T. When S comes in, if it match, that's cool. And then second one, we can match, and that's the smallest. Well, let's try that. Let's try that. So what I say is a hash map, right? So I letter in enumerate S. Well, of course, let's do this one first. If len S is larger than len T, hash map letter equals to minimum nope if letter not a hash map letter what equal to I. And then after this is done, then we can compare to this thing for every t, right? And for letter in t, so current index shall equal to, let's say current index is -1, okay? And then if letter not in hash map, that is immediately false, right? Otherwise, if hash map shall equal get letter -2, right? If this is smaller than index equal to this, so if index is smaller than current index, turn false. Otherwise, actually smaller or equal to. Otherwise, current index equals index. So and I'll return true. How about this one? Huh. Have A, B, C, A, B, and C. Wait, why would this be false? Alright, let's try. Let's print a hash map. Zero HB GD. Yeah. Wait, hold on. Now we pass. What? Oh, 1. My bad. Alright, letter in T is not, so I return -2. Right? And -2 was essentially return false. How? Yeah, let's do hash map. Yeah, hash map is fine. Print letter and index. Oh, I think this is S. Wow, weak test cases. Yeah, anyway, this I think is the way to resolve the issue. Let's try this one. This can solve the follow-up question. We build a hash map for each letter in T with its earliest occurrence, right? With the index and the index of its earliest occurrence. Then we can compare each letter in T to the hash map. This way, we build the hash map once, right, and can run the checking for all S. I always confuse the two. Checking for all S. So we'll run the checking for all S in O len S time. Yeah, I'm not sure this one will be faster, but I think it's better. Oh, ha! Got beat immediately. Yeah, it's true. A, B. True, man. No, I cannot. And then we are doing binary search, right? We just do binary search and then try to find. Yeah. I was trying. I thought I can avoid binary search. just do binary search. So this will be different. This will just be, what should I say? Now we can do default dict. Yeah, and this one we'll call it default dict list. And I'll just say hash map letter dot append I, right? I have the current index. And every time we find it, we find something bigger than the current index, right? So do index shall be bisect right hash map letter dot get. Oh, hold on. If letter not in hash map, return false immediately. Otherwise, we do this and current index, right? What if I have like a like that? Yeah, what if I do have that? On binary search, we always match the latest one. I should match the first one. You know what? I don't know. What's the good solution for this? Length of t. Yeah, we have this, but I don't like this. But that is the same solution as I had. Right? It's the same solution as I had. I want something new. I want something different. DP and 2 pointers. Longest subsequence. What? That's stupid. I'm trying to see if there are better. I think it's the same idea. I just don't want to keep thinking about this. Alright, so maybe I am on the right path, but but I have issue of how do you handle. Yeah, I realize it is bisect left. Oh, that's fine. My bad. It will be different. It will just be different values. We just keep incrementing. Yeah. All right. So again, it's not gonna be bisect left. It's a bisect right. It's gonna be bisect left. Okay. And I'll always find one. I will always increment by one. Oh, then it doesn't matter if it's bisect left or bisect right. This is not gonna be repeating. These are all different values. They're all different values. And what I want to find, right, is +1 and so the current +1, and then trying to find, maybe bisect left is better, because bisect left will be that, right? If it's the same, it will be that one. If it's not the same, it has to be something larger than, yeah, so it is bisect left will be easier. So index, that's fine. And then we simply say current index equals hash map letter index. So we don't have to change. I'm gonna start with -1. So we can start. It doesn't matter which one we start. As long as it finds the index and now we go index. Yeah, I think this one should be right. Yeah. And all indices of its occurrences, right? Then we can compare each letter in S to the hash map using binary search. In O, with log O-lanus, right, times, that's a log ln t time. List out of range. Oh, interesting. There's still some stuff that need to work out. That's that's false. Oh yeah, it will have out of range. We are looking for this. If it's out of range, that means we don't have it. Right? Does that mean we don't have it? Hold on, let me think about it. And it actually should be its index +1, actually, I think. And then we have, because the current index has to be, so like has to be larger or equal to this, right? Have to be larger or equal to this. Yeah, so we can actually start with 0. And it should be larger or equal to this. And if it matches, because it's bisect left, so we'll go a little bit front, right? Which means it will return this one, which is good. So now we need is index. So if index, right, if index is equal to len hash map letter, then we shall return false. Yeah, there's no match. This is 60 milliseconds. 23. Alright, so I guess we're done for yesterday. Alright, I'll see you guys later. Adios.